Hello, and welcome to what is hopefully going to be the last in this series of where I'm answering every question in my textbook, in the Crack Maths Functional Skills Level 2 workbook, even that is going to be coming out in the next week or so. This is the final proof check, so we'll just go through doing the final edit, tweaking the questions, make sure that everything works. The pages look like this page here. They've all got a topic on them, numbered 1 to 70, with a QR code in the corner. If you scan this QR code, it takes you to the lesson. Today what I'm doing is I'm simply working through the questions for one last final time, just to make sure that everything is perfect before it all gets sent off to the printers. Well, not to the printers, it's going to be on print on demand. So, but that means you will be able to buy it. There'll be a link here and there'll be a link in the website. So if that's something that you feel like you could benefit from, it'd be a really worthwhile thing to do. I know that a lot of my students just like sometimes having something that they can work through systematically in order to kind of repeat all the stuff that they need. And yeah. So anyway, I am going to get started, and yeah, that'll be that. Okay, so the first topic that we've got at the moment, as you can probably see, is calculate probability from a two-way table. Okay, so let's begin. So these are the practice questions, and the first one says, the two-way table compares methods of commuting for two different cities. So here we go, we've got the two-way table here. We've got commuting method on the top, so car, bus, train. We've got city on the side, Birmingham and London. The question says, what is the probability that a participant was from Birmingham? Okay, so I can see here, if I go down here, that there's 20 people from Birmingham, and altogether there were 280 people on the table. So the answer to A is going to be, it's going to be 70 out of 280. Now, you don't it doesn't say to simplify this, so you don't have to. 70 out of 280. So I will actually just leave it like that, but I will just actually put in brackets that is a quarter. Okay, and then B, what is the probability a participant from London took the train? So we're looking at just the Londoners, so that would be 73 out of 110. Okay, question 2. We've got the two-way table shows the results from a test taken at a college by students in year 1 or year 2 of their course. Here we go, so there's the college group, year 1, year 2. Exam result, yeah, pass, fail, total. Yeah, all of this looks to be in good order. What is the probability? A, what was the probability that someone in year 1 passed? Okay, the probability that someone in year 1 passed, so they were in year 1, so it's out of the 9, and they passed, so that's 4 people. Okay, and then we've got B. What is the probability that of the people who failed, they were in their first year? So the people that failed were these 11 people. The probability that they were in their first year, there's 5 in their first year out of those 11. So that'll be 5 out of 11. Okay. Question 3. The two-way table shows the results of a student who took both maths. The results of students who took both maths and English exams. Okay, 1 second. The English is capitalised and maths isn't, because I guess they're both the names of subjects. I think I need to be consistent there, so I'm going to capitalise maths as well. Sorry about this. 1 second. So there we go. Yeah, and here we go, it's there as well. Right, so what is the probability that the person chosen at random passed both exams. So here we are, they passed both of them, they're chosen at random. So that means it's out of everyone, so it's out of 40. And the people that passed both exams are here, so 17 out of 40. And then B, what is the probability that a student who passed maths failed English? Okay, so here's the pass-fail for maths. So they passed maths, so there's 20 of them here that passed maths. Okay, and then out of those, 23 failed English. Okay. Question 4. The two-way table compares favourite forms of exercise used by people in their 20s compared to people in their 30s. A. What is the probability that a participant selected at random was in their 30s and liked to cycle? So there's that keyword at random, they're just selected. So it's out of the whole 100 people. And participant, they were in their 30s and liked to cycle. So that's these 4 people here. So that'll be 4 out of 100. And then B, what was the probability that a participant in their 30s liked to cycle? Ah, okay. So this is a bit different. So this is interesting. So this is, what is the probability of a participant in their 30s like to cycle? So that means we're just looking at the 30-year-olds. So here, so these people here. So that is going to be out of 50. And it was 4. There we go. Right, let's have a look at question 5. And then we might mark these and then do the other 10. So Barry made 60 predictions on if a football team was going to win or lose. The two-way table shows the outcomes of those predictions. A. How many games did Barry predict the football team would win? Okay, so here we go. How many games did he predict would win? So these 28. Yeah, so 28 games. Oh, yeah. How many? Oh no. 1 second. This is confusing. How many games did Barry predict the football team would win? So this is the win row. So he predicted out of the 60 games, they'd win 41 of them. So the answer to that is 41 games. Okay, and then B. What is the probability that a game Barry predicted as a loss would turn out to be a win? So here's the games that he predicted that they would lose. Okay, so it's out of 19. Okay, because there was 19 games that he predicted would be lost. And how many of those 19 games did they win? 12. Well, so he's not very good at predicting stuff. Okay. Right. Question 6. A poll was conducted at a local park asking adults and children whether they preferred cats or dogs. The two-way table shows the outcomes. Yeah, it does. A. What is the probability that a participant selected at random was a child who preferred dogs? So at random, child that preferred dogs, 39 children. There's 39 children that like dogs. And there's 80 people in total. And then B. What is the probability that an adult participant liked cats? So let's look for that. An adult participant that likes cats. We've got 24 adults and 18 of them liked cats. Okay, right. Let's get these ones marked and then we'll do some more. Okay. So let's get the answer scheme up. Here we go. And then what is here? Okay. Okay. Yep, so I haven't gone for the simplified things. That's fine. So with probability, often people like to keep the unsimplified form because it gives you a little bit more information, especially when it's out of real data. So that's there. Here we've got 4 out of 9 and 5 out of 11. Here we've got 17 out of 40 and 3 out of 20. Yeah, this is nice. Here we've got 4 out of 100 and 4 out of 50. Yeah. 41 games. 12 out of 19. And then 39 out of 80. Yeah, and 18 out of 24. Okay, let's continue with the next ones, and then we can get these marked as well. Okay, the two-way table shows the results of a chess tournament. What is the probability that a participant chosen at random was over 60 and lost? Okay, chosen at random, over 60 and lost. So there were 16 of people that were over 60 and lost, and there was 80 people in total. Okay. Part B. What is the probability that a participant who was under 60 who won? What is the probability that a participant who won was under 60? Okay. So we're looking for a participant that won that was under 60. Here's all the under 60. Oh no, so we're looking at the winners. So we're looking at this group here. These are all the participants that won. The probability that they were under 60 would have been 3 out of 26. Okay. Question 8. The two-way table shows the holiday destinations of a group of adults and whether or not they went on holiday with children. Okay. A. What is the probability that someone chosen at random had a holiday at home with children? Okay. So chosen at random, so that's out of the whole thing. At home with children, home here, children here. So 8 of them. So 8 out of 40 people had holidays at home with their children. Okay. Number B, letter B, B even. What is the probability that someone went abroad, had children with them? What is the probability that someone that went abroad had children with them? Okay, so we're just looking at the people that went abroad. So that's this section here. So there's 23 people that went abroad and 12 of them had children. Okay, right. Question 9. The two-way table shows how many hours of driving lessons a person has had and whether or not they passed their driving test. A. What is the probability that someone chosen at random passed their driving test in less than 20 hours of lessons? Okay, so less than 20 hours of lessons, pass. So here we go, that's these 17 people, and it's at random, so it is out of everyone. So it's 17 out of 40. And then here we've got B. We're looking at what is the probability that out of those who failed, they had more than 20 hours of driving lessons. So here we go, the people that failed were here, and so that's out of 20. And then how many of those people had more than 20 hours of driving lessons? Well, that's these 8. So 8 out of 20 for that one. Okay. And that's that, yeah. Only 9 questions for this one. Okay. So let's get these ones marked. And then we will do that. So, okay, we might as well do these while we're on this page. 8 out of 20. 17 out of 40. Yeah. Question 7. 16 out of 80. And 3 out of 26. And then question 8, we've got 8 out of 40 and 12 out of 23. Brilliant. Okay, on to the scenario ones. Okay, now the scenario ones are exactly the same as well, really, for these, because there's no way of having these questions without having a scenario behind it. So it's just more practice. But this is one of these things, it's a topic that people really like to practice in functional skills, because the wording is the tricky part. Right, question 1. The two-way table so the questions are the same actually, they're just different questions of the same tables. The two-way tables compare the methods of commuting from 2 different cities. What is the probability that participant was from London? Okay, so here we go. What is the probability a participant was from London? So that's going to be A, will be 110 out of 280. Okay, and then B, what we have here is we have got what is the probability that a participant selected from Birmingham commuted on the train? So here we go, Birmingham, we're looking at these people here. So it's out of 70. How many of those people went on the train? 12. Okay. There we go. Question 2. The two-way table shows the results from a test taken at college by students in either their first year, in either year 1 or year 2 of their course. A. What is the probability that someone in year 1 failed their exam? Okay, somebody in year 1 failed their exam. So there's 9 people in year 1 and 5 of them failed. And then B, what is the probability that of the people who passed, they were in their first year? The people who passed, they were in their first year. So it's these 9 people here. 9, and so it'll be 4 out of 9. Okay, right. Question 3. The two-way table shows the results of the students who took both maths and English exams. What is the probability someone selected at random failed both exams? So that will be these 8 people here that failed both exams. Okay, so that's out of 40, and that will be 8. Now, I do remember I made the change in the other one because maths also needs to be capitalised, just like to match this one here. So this is question 3, isn't it? Yep, there we go. Because it's the name of a subject here, so it gets a capital letter, I think. Oh, there we go. That one was capitalised. Okay. Right. So, and then B. What is the probability that out of the people who passed English, they failed maths? So here's the people that passed English. Okay, so there's 29 of them. And then 12 of them failed maths. Okay, right. Question 4. The two-way table compares favourite forms of exercise used by people in their 20s compared to people in their 30s. What is the probability that a participant chosen at random was under 30 and liked to cycle? Under 30, liked to cycle, that's these 11 people here. Okay, so that's 11 out of 100. Okay, so, and then we've got B. What is the probability that a participant in their 30s didn't choose cycling? Oh, okay. Right, participants in their 30s, so that was these ones. So it's out of 50. Now, if 11 of these 50 people chose cycling, that means that 50 take away 11, which is 39, people did not choose cycling. So there we go, 39 out of 50. Question 5. Barry made 60 predictions on if a football team was going to win or lose. The two-way table shows the outcomes of those predictions. A. How many games did Barry predict the football team would lose? So he predicted they'd lose 19 games. Okay. B. What is the probability that a game Barry predicted the team would win would turn out to be a loss? Okay, so here's his predictions. He predicted all of these games were going to win. So there's 41 games he thought they were going to win. How many of them did they lose? 13. Okay. And let's do question 6 as well. Well, we might as well just finish this round actually, because there's only 9 questions. So a poll was conducted at a local park among adults and children about whether they preferred cats or dogs. What is the probability that someone chosen at random was an adult that preferred dogs? Okay, let's have a look. So if it's an adult that preferred dogs, chosen at random, that's these 6 people here. Okay, and it's at random, so it's out of everyone. So that's 6 out of 80. Okay, B. What was the probability that a child preferred cats? Okay, so a child preferred cats. So that means we're looking at the children. We're not talking about the adults here. So there's 56 children. And 17 of them preferred cats. So 17 out of 56. Right, question 7. The two-way table shows the results of a chess tournament. What is the probability that a participant chosen at random was under 30 and lost? Under 30 and lost, that's these 10 people. And it's at random, so it's out of everyone. So it's going to be 10 out of 80. And then we've got B here. What is the probability that a participant who lost was under 60? Okay, so we've got 10 that lost. What is the probability? What is the probability a participant who lost? So we're looking at the losers. Okay, what was probably there under 60? Okay, right, here we go. So that is going to be 26 it's out of. And then 10 of them lost. So there we go. So 10 out of 26. Question 8, we've got the two-way table shows holiday destinations of a group of adults and whether or not they went on holiday with children. A, what is the probability that someone chosen at random had a holiday at home with no children? They're chosen at random, they holidayed at home with no children. That's home and no, so that's these 9 people here. So that's going to be 9 out of random, so it's everybody. Oh, it's not 40, that it's not 80, it's 40. And then B, what is the probability that a participant went abroad? Okay, what is the probability that the participant went abroad? Well, 23 out of 40. Okay, let's just do question 9, and then that's that section done. Okay, the two-way table shows how many hours of driving lessons a person has had and whether or not they passed their driving test. What is the probability someone chosen at random passed their test and had over 20 hours of lessons? So here's the people that passed. Here's the ones that passed with over 20 hours. So that's 3. And it's out of random. It's at random, isn't it? So it's out of everyone. Okay. So it's 3 out of 40. And then B, what is the probability that our participant passed? Well, that's going to be 20 out of 40. Because there's 20, yeah. Okay, and I believe that's that. Oh, tree diagrams next. That'll be fun. Okay, so let me just minimize this. Let me minimize that as well. And here's the answers. So let's go back to the start of these questions. Okay, so here we go. We have got question 1A, which is... No, 1 second. Just enlarge these a little bit. So we've got 110 out. Oh, that's a mistake in the answers. Then that should say 280. Okay, so let's get to the answers. Um, 110 out of 280. 12 out of 70. Yep. 5 out of 9. Yep. 4 out of 9. Yep. 8 out of 40. 12 out of 29. 11 out of 100. 46 out of 50. Ooh, interesting. Oh, I did. Yeah, they're correct. I got the wrong subgroup. It said, what is the probability of a participant in their 30s? I wonder if this is the problem. No, that's fine. This is common to write it like this. Right. Yeah, 46 out of 50. Yeah, mark scheme is correct. 19 games, yeah. 13 out of 41, yeah. 6 out of 80, yeah. 17 out of 56. 10 out of 80. 10 out of 26. 9 out of 40, yep. 23 out of 40, yep. And then 3 out of 40 and 20 out of 40. Wonderful. Right, okay. Let's get started with probability trees. So here we go. Right, so the way probability trees work is you multiply along the branches, and then the pairs of branches add up to 1. So you'll notice here, because basically with probability, if you think about it in terms of percentages, it's 100% chance of things happening or not happening. And then so something either happens or it doesn't happen. So that has to equal either 1, 100%, or a full fraction. So, okay, right, let's have a read of this then. The probability that event 1 happens is 0.7. The probability that event 2 happens is 0.6. What is the probability that both events happen? Okay, so that's going to be A. We're going to do 0.7 times 0.6, which equals 0.42. Okay, and then B. What is the probability that neither events happen? So that's this root here, so that is going to be 0.3 from there, because that doesn't happen, and then times 0.4 for here, and that will be 0.12. Okay, question 2. The probability that event 1 happens is 0.9. The probability that event 2 happens is 0.2. What is the probability that both events happen? What is the probability that neither events happen? So A, both events, is going to be this root, so 0.9 times 0.2. 0.18. And then B, that neither events happen, 0.1 times 0.8, which will be 0.08. Okay. We've got working out bits here, so I will just do some underlining so that the answers are clear when we go back to look at it. Okay, here we go. What is the probability? The probability that event 1 happens is 0.4. The probability that event 2 happens is 0.25. What is the probability that both events happen? What is the probability that neither events happen? Okay, so we've got here A is 0.4 times 0.25. Okay, so that's going to be okay, right, let me get the calculator out. I feel like it's going to be 1. 0.1 even. Yeah. What is the probability that neither events happen? So we've got 0.6 times 0.75. For what is the probability? The probability that event 1 happens is 1/5. The probability that event 2 happens is 3/4. What is the probability that both events happen? Okay, right, so here we go. Event 1 happens, event 2 happens. We've got 1/5 times 3/4, which will be 3/20. And then for B, what is the probability that neither events happen? That's going to be 4/5 times 1/4, which will equal 4/20. Okay, question 5. What we have here is we have the probability that event 1 happens is 1 out of 10. The probability that event 2 happens is 2 out of 7. What is the probability that both events happen? Okay, so we've got 1/10 times 2/7 equals 20. No, it equals 2/70. And then B, we've got what is the probability that neither events happen? So that would be 9/10 times 5/7, which will be 45/70. Okay, right. Okay, questions. Now let's mark the first 5. It gives me a nice feel for what's been going on actually if we mark them in 5s. Okay, so let's just move this over here. Okay, so we've got excellent 0.4.2, 0.12, 0.18, 0.8, 0.8 even, 0.1, 0.45, 3/20, 4/20, 2/70, 45/70. Okay, right, so here we go, question 6. Let's continue on. The probability that event 1 happens is 1/4. The probability that event 2 happens is 4/5. What is the probability that both events happen? What is the probability that neither events happen? Okay, so A, we've got 1/4 times 4/5. And then B, we've got 4/20. And then B, we've got 3/4 times 1/5, which is 3/2. Were they the answers that we just had on the other page? They were. Is this exactly the same question? I think this is exactly the same question. Right, I think... yes. Here we go. 1 second. That's it there. Oh no, it's not exactly the same. It has changed the way round it is. It's just the fractions are the same. So yeah, that's fine. I'm fine with that. The skill is the same. I know that the numbers are the same, but it's all about practicing the skill, and the questions are different, so there's no need to shake things up with that. Okay. Question... Ooh, we don't have anything on here. The probability that event 1 happens is 10%. The probability that event 2 happens is 30%. What is the probability that both events will happen? What is the probability that neither events will happen? Ooh, okay, we've got something. So we've got to put these on. I'm going to put them on as decimals. So event 1 happens is 0.1. Event 2 happens is 0.3. So that's 0.9. So that's 0.9. That will be 0. No, that's not 0.9. That's 0.3. So that's 0.7, 0.3, 0.7. Okay. So here we go. We have got, first of all, probability that both events will happen, 0.1 times 0.3. And then B, probability that neither events will happen, 0.9 times 0.7. So this is 0.03. This equals 0.27. Okay. No. 0.72. There we go. Right. The probability that one event happens is 45%. The probability that event 2 happens is 22%. What is the probability that both events happen? What is the probability that neither events happen? So both events happening, well, 1 second. So 45 is 0.45. 22 is 0.22. That would make this 0.55, 0.78, 0.22, 0.78. A, the probability that both events happen, that is going to be 0.45 times 0.22, and B will be 0.55 times 0.78. Let's do this on the calculator. So here we go. Oh, interesting. Okay, there we go. So that equals 0.099. Okay, and then 0.55 times 0.78 equals 0.429. Okay, right. I'm just going to let you look at question 9 quickly. I'll be back very shortly. Okay, right, let's have a look. So the probability that event 1 happens is 32.5%, so that's 0.325. The probability that event 2 happens is 88.5%, so that's 0.885. This would be 0.1 minus 675, and then good. Okay, what is the probability that both events happen? So we've got and then here we've got no 10th question there, that's fine. So let's go get these marked. Here we go. We're starting from question 6. Okay, so 4 out of 20, 3 out of 20. And then we've got 3%, 63%. Okay, yeah, that's fine. You can have that as a percentage. Or well, let me update that, because I think it's fine to leave your probabilities in any form you like. So I could put this as, where are we? I think I will add the decimals just in brackets next to that, just so that is not confusing. Okay, so it's likely that that's annoying. Oh no, they didn't. Okay, right, so 0.3%. Oh my gosh, I put 7 times 9 was 0.72. That's not at all. And actually I've got that wrong. It's 0.63. Okay, 1 second. Yeah, that is correct. 6-3. There we go. Right, and then, okay, I'm just going to quickly get the rest of these marked, and I'll do the rest of these all together. So here we go. So we have got, where are we? Yeah, that's fine. Yeah, 0.99, yeah, that's the same, just written in a different form. And then here we go, 28.76, yeah, and then 7.76, that is correct as well. I just need to add these decimals into the mark scheme, so let's just do that. Okay, so that's actually, you know what I'm going to have to do? Okay. Right. Okay, that's nice. That's done. I'm going to have to do the same thing for that, aren't I? Oh, well, 1 second. Right, anyway, so those questions were correct. So let's move on. Okay. Here we go. We've now got the scenario questions. So let's have a go at these. So here we go. Bob has a 0.6 chance of driving to work and a 0.7 chance of wearing a tie. The probability tree shows this information. What is the probability that he both drives and wears a tie? So you've got here. So A is 0.6 times 0.7. Okay. Which will be B is there is a 40% chance of rain tomorrow and an 80% chance that Lily remembers to bring her umbrella. A, what is the probability that it both rains and Lily brings her umbrella? Okay, so rains here and Lily brings her umbrella, so that's going to be 0.4 times 0.8, which would be 0.32. And then here we've got, what is the probability that it rains and Lily forgets her umbrella? Okay, so rains up here and no umbrella here. So we've got 0.4 and 0.2. So that's going to be 0.4 times 0.2, which will be 0.08. Okay, great. Question 3. Jasmine has 3/4 chance of ordering a burger for lunch and a 3/5 chance of getting a bottle of water to drink. What is the probability that she orders a burger and gets a bottle of water? Okay, so orders a burger and gets a bottle of water, so that's that top root there, so that is 3/4 times 3/5, which will be 9/20. B. What is the probability that she doesn't order a burger but gets water? Okay, so doesn't order a burger but does get water. So 1/4 and 3/5. So 1/4 times 3/5. So that'll be 3/20. Okay. Javine has a 3/10 chance of going to the gym and a 9/10 chance of meeting her friend there. A. What is the probability that she goes to the gym and meets her friend? Okay, so we've got A, which is 3/10 times 9/10, which will be 27/100. And then B, we've got, what is the probability that she goes to the gym but doesn't meet her friend? Okay, so it's 3/10 for that, times 1/10, and that will be 3/100. Question 5. Jamie has a 0.85 chance of studying for her maths test and a 0.5 chance of getting takeout dinner. A. What is the probability that Jamie studies and eats takeout for dinner? Okay, studies, gets takeout. So here we go. 0.85 times 0.5. And then let's find out, we'll need the calculator for that one, I think. It's got 0.85 times 0.5. So there we go, that's 0.425. And then B, what is the probability that they don't study but do get takeout for dinner? Okay, so they don't study, which is 0.15, and they do get takeout for dinner. So we've got here 0.15 times 0.5. They don't study, but they do get takeout for dinner. Okay, let's work out what that is. We've got 0.15 times, I guess that's 0.075. Okay, right. James has a very Jamie-based page. Actually, let's mark those first 5 first, and then we'll continue with these. Okay, 66 scenario, so that's these ones here. So we've got 0.42, 0.28. Oh, right, that's my bad. What is the probability that he doesn't drive but does wear a tie? So it's this route here. Okay, so that is wrong. 0.4 times 0.7, and that is 0.28. So the mark scheme was correct. Okay. Next one we've got 0.32, 0.08. Yeah. Here we've got question 3, 9/20 and 3/20. Wonderful. Question 4, we've got 27/100 and 3/100. Yeah. Question 5, we've got 0.4. Yeah, very good. Okay, right. So next, we've got these ones. So let's continue on with this. James has a 0.7 chance of going to the supermarket and a 0.4 chance of buying bread. What is the probability that he both goes to the supermarket and buys bread? Okay, so that's going to be A. So that's going to be 0.7 times 0.4. So that would be 0.28. What is the probability he doesn't go to the supermarkets? That's actually just 0.3. Okay. Question 7. Mark has a 50% chance of going to see a movie and a 60% chance of eating popcorn while watching it. Okay, so let's put this on here. So that's 0.5. The popcorn is 0.6. That's 0.4. And this is 0.5. What is the probability he both watches a movie and eats popcorn? So that will be 0.3. Okay, well, just because that's 0.5 times 0.6 equals 0.3. And then B, we've got what is the probability that he watches a movie but doesn't eat popcorn? So that's going to be 0.5 times 0.4 is 0.2. Okay, question 8. Lionel has a 72% chance of bringing his lunch to work and a 63% chance of being first to the photocopier. A. What is the probability that he both brings his lunch and gets to the photocopier first? So that's 0.72 and that is 0.63. So A will be 0.72 times 0.63. Let's find out what that gives. 0.72 times 0.63. Okay, so that will be 0.4536. And then I remember from the last round of answers, it might well be in the answer scheme as 45.36%. The next one, what is the probability that he brings his lunch but misses out on the photocopier? So that'll be 0.37 here. So we're going to do 0.72 times 0.37. And let's see what that gives us. 0.72 times. Here we go. That's 0.2664, which would also be 26.64%. Okay, right. Question 9. And it says here that Mo has a 80% chance of exercising in the morning and a 65% chance of drinking a protein shake afterwards. What is the probability that he both exercises and drinks a protein shake? So, one second, we've got here 0.8, 0.65, that would be 0.35, that would be 0.2. Okay, so A is going to be he exercises and drinks the protein shakes. That's 0.8 times 0.65. Okay, we go 0.8 times. Oh, no. What was that? Well, I guess it's going to be 0.52. There we go. And then B, what is the probability that he doesn't exercise? That's just 0.2 or 20%. Okay, great. Let's get these questions marked. And I think we'll need to edit the mark scheme as well to put in those decimals. Here we go. So 0.28, yep. 0.3. 30%, oh yeah. Yep. And 20%, yep, that's what these are. I'll do them all in one go at the end. 45.36%, yep. 26.64%. 52% and 20%. Okay, so let's fix those. Okay, so here we go. It's these ones here. Let's just right, there we go. That is that done. Okay. Right. Topic 67, completing two-way tables. Okay, here we go. So I'm going to get out the calculator for this one. So here we go, we've got 232. Take away 125. Let me. Okay. Oh, that shouldn't be there. Well, it should be a different colour. What's it? Oh no, it's an image. Is it an image? I don't know, I can edit it, that's nice. Yeah, that's fine. I can just delete that. That's not needed. So let's make sure I can work out that though. 30. Yeah. Okay. Oh, wow, that was quick. There's only 6 of them. Okay, great. Let's get that marked. Okay. Yeah. 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 Okay, great. Let's do the scenario. 67. We're so close to the end. Right. Here we go. So the two-way table compares the methods of commuting for participants in 2 different cities. Complete the table to answer A. What is the probability that a participant selected at random was from Birmingham? B. What is the probability that a participant from London took the train? So let's complete the table. and then we can answer the question. So we've got here, that would be 19, and then this will be 60 as well, 61, 47, 13. Now, the only problem with these questions actually is I could have answered them without completing the table. Okay, so complete the table to answer doesn't necessarily fulfill the criteria, because if you're completing it to answer, then that suggests that the questions are based on whether or not you can complete the table. But let me, so maybe I'll change the wording for that. Okay, so what have we got? What is the probability that a participant selected at random was from Birmingham? So that is 60 out of 120. What is the probability the participant from London took the train? So that is 21 out of 60. Okay. Question 2. What is the probability? The two-way table shows the results from a test taken by college students in either year 1 or year 2 of their course. Complete the table to answer A. What is the probability that someone in year 1 passed? Or B. What is the probability that what is the probability that of the people who failed, they were in their first year? Okay, so this is fine. For this one, I need to fill it out. Okay, so that's going to be 33. That's going to be 11. That's going to be 35. This is going to be 90. Now, what is the probability that someone in year 1 passed? Okay, so that's 22 out of 55. So I didn't need the table to answer that. What is the probability that of the people who failed, they were in their first year? Okay, so I did need the table for this one. Yeah, I think I'm just going to say complete the table, then answer the questions and answer the questions below. I think that's what it needs. let's continue. Right, so that's been fixed. That's 11. The two-way table shows the results of students who took... this one again, capitalising the maths. Alright, okay, so A, what is the probability someone passed both exams? So pass, 5 out of 30. Okay, what is the probability that someone who passed maths failed English? So here we go. So that's going to be 5 out of 14. No, that's not right. That's passed. It's going to be 9 out of 14. Passed maths, failed English. Yeah. The two-way table compares forms of exercise used by people in their 20s compared to people in their 30s. Complete the table to answer. Okay. That's 98. And then oh. Okay, right. Here we go. What is the probability that a participant selected at random was in their 30s and liked to cycle? In their 30s, liked to cycle, 20 out of 200. What is the probability that among the participants in their 30s, they liked cycling? That among participants in... That doesn't make sense. What was the probability that a participant in their 30s? What is the probability that a participant in their 30s liked cycling? Yeah, what is the probability that a participant in their 30s liked cycling? Yeah, perfect. That's much better. So here we go. A participant in their 30s that liked cycling. So it's out of 102 and it's 20 as well. Right. Barry made predictions on a football team winning or losing. The table shows the outcomes of those predictions. Complete the table to answer. Okay, so that's going to be 99. That's going to be 93. So that means this is 82, which means this is 88. Okay. A, how many games did Barry predict the football team would win? 101. B, what is the probability that a game Barry predicted as a loss would actually turn out to be a win? A game that he predicted as a loss would turn out to be a win. So he predicted 99 loses and 88 of them won. Okay, right. Let's get these ones marked and then we'll do the last four. Here we go. Right, what is going? Okay. Ah, this is a problem. Ah. Right, I need to rethink these questions. Because if we're going to mark these answers, but these answers can happen without the question, then that's a problem. Okay, right. I'll have to do this. I'll do this on my own time. Right, but let's see if these are right anyway. Yep, they are correct. Oh, I know what I can do. Got it. Right, don't worry. I've got this. I've got a quick solution. Okay. Yeah. Right. Okay. So A. Oh, have I got this one wrong? What is the A? What is the probability that a participant selected at random was in their 30s and liked to cycle? 8 out of 200. Ah, so I've got it wrong here. It should be 20 because this is under 30. That's someone that's under 30. Should I change the question or the answer? Let's change the question. What under? Okay, right. That's fine. Okay. Right. Okay. Okay, so here is my plan. What I need to do is I just need to remove the information that we need from the charts. Okay, so send to the back. So what is the probability that a participant selected was from Birmingham? So this needs to go. And then I can put 60 here. Text. Right, so that can go. What was the probability that our participant from London took the train? And I actually can just delete that because you can still work that out because you can get this number and then you can get that number. Okay. Right. Oh, in which case, complete the table to answer the questions was right. Completed. There we go. I think that's fine. Right, the two-way table. What is the probability that someone in year 1 passed? Okay, so okay, can I get that still? I can get this number, then I can get that number. Yep. What is the probability that of the people who failed, they were in their first year? Excellent, they need to work that out. Okay. Question 3. What is the probability that someone passed both exams? Perfect, it's not there. What is the probability that someone who passed maths failed English? Yeah, that one's fine. What is the probability that a participant selected at random was under 30 and liked to cycle? Great, it's not there. What is the probability that a participant in their 30s liked cycling? Great, that's not there either. Okay. How many games did Barry predict the football team would win? Okay, so I need to get rid of this. Now, can I still do this? Yep, I can get that, I can get that, I can get that. Right. Right, okay, let me complete these next 6 and then I will think about how to sort out the questions. Okay, so, that wasn't so bad after all. Right, there we go. Right, so we've got, okay, here we go. Question 6. A poll at a local park asked adults and children whether they preferred cats or dogs. Complete the table to answer. Okay, right. Can I answer these questions yet? What is the probability a randomly selected participant was a child who preferred dogs? Excellent. It's not there. Out of the adults, what is the probability they preferred cats? Excellent. We don't have the total. So these are both fine. So we don't have to do anything there, but let's work this stuff out. That's going to be 4, that'll be 11, this will be 4, this will be 20. Oh no, 1 second, I'm ruining my system. I've done it in red, and I've already ticked it. So let me remove the ticks. Right, it can stay in red, that's fine. Okay, right. Question 7. Okay, the two-way table shows the results of a chess tournament. What is the probability that a participant chosen at random was over 60 and lost? Over 60 lost. Okay, right. But I suspect, yeah, I can get rid of that. Oh, right. So let's go to, well, anyway, I'll do this first. 12, 9, 3, 8. Okay. Over 60 and lost was 7 out of 30. What is the probability that they were what is the probability that out of the participants who won, they were under 60? So that is 2 out of 8. Okay. I'll star this to remember that we're coming back to it. 8. The two-way table shows the holiday destinations of a group of adults and whether or not they went on holiday with children. A. What is the probability that someone chosen at random had a holiday at home with children? Okay, that's fine. Okay, we need to fill it out to solve that. What is the probability that out of the participants who went abroad, they had children? Okay, that's a problem. We can do that one already. In fact, that's what I need to do. What is probability they were over 60 and lost? Yep. And what is the probability that they won? So yeah, I'll put a cross by those so I remember. Okay. Right, now let's do this. So this is going to be 1, 3, 2. This will be, what's this going to be? 84. 84 take away 30, 54. Yeah, that's right. And then here. And then, yeah, okay, fine. What is the probability that someone chosen at random had a holiday at home with children? What is the probability that out of the participants who went abroad, so out of the 92, they had children? Okay, 9. The two-way table shows the number of hours of driving lessons participants took and whether or not they passed their driving test. Complete the table to answer the questions. A. What is the probability that someone chosen at random passed their driving test with less than 20 hours? Excellent, that's fine. What is the probability that out of those who failed, they had more than 20 hours of lessons? Excellent, they're both fine. Okay, so that's 68. This will be 45. This will be 53. And then this would be 48. Okay, and then A is going to be probably pass their driving test with less than 20 hours. Passed, what is probably someone chosen at random, under 20, 53 out of 169. And then B, what is the probability that out of those who failed, they had more than 20 hours of lessons? Out of those that failed, they had more than 20 hours of lessons. So 45 out of 93. Okay, was there a 10th one? I feel like there won't be. Yeah. Okay, right, so first things first, let's mark, and then let's correct. Okay, so question 6. Oh, I didn't even mark it. Oh no, I didn't do it. 1 second, don't look, Ian, don't look. Okay. Okay. What is the probability that is, okay, so a child selected at random was a child who preferred dogs. So that was 4 out of 20. And then B, out of the adults, what is the probability they preferred cats? Out of the adults, that's 11. It's probably they preferred cats, 4. Okay, right, let's mark this now. Okay, so here we go. Oh, the next topic's very easy, and is the one after that. Perfect. So 4 out of 20, 4 out of 11. Great. 7 out of 30, 2 out of 8. Okay, but we need to fix it. So here we go. That one was fine. So I think we can just send to the back. I think we can just get rid of that. What was the probability out of the participants who won? They were under 60. Oh, you know what? That's fine. Actually, let's get rid of that anyway. Because if I get rid of that, they can work out this one from here. They can then work out this one, and then they can work out that one. So that's fine. Right, let's go back. Okay, here we go. Question 8. 94 out of 200. Yep. 38 out of 92. But the second one we can do too easily. 38 out of 92. Can we just get rid of the 38? Right, I can work out this. I can work out this. And I can work out that. Yep. Fine. Right. Last one. Okay, so here we go. We have got 53 out of 169. Yep. And we have got 45 out of 93. And it says I've ticked both of these because I could already do them. Okay, wonderful. Right. Topic 68. There we go. Right. So, if the probability of an event happening is a half, what is the probability it doesn't happen? Well, that would be a half. Okay. If the probability of an event happening is 0.75, what is the probability the event doesn't happen? Well, that's 0.25. If the probability of an event happening is 80%, what is probability it doesn't happen? 20%. The probability of an event happening is 3 over 4. The probability it doesn't happen is 1 over 4. If the probability of an event happening is 0.6, what is the probability it doesn't happen? That's 0.4. If the probability of an event happening is 25%, what is the probability it doesn't happen? So that's 0.75. No, well, it's 7. Let's keep with what they've got. So let's say 75%. Okay. If the probability of an event happening is 0.2, what is the probability the event doesn't happen? Well, that would be 0.8. If the probability of an event happening is 7 over 8, what is the probability the event doesn't happen? That's 1/8. If the probability of an event happening is 50%, what is the probability it doesn't happen? That is also 50%. If the probability of an event happening is 0.9, what is the probability that that event doesn't happen? That is 0.1. Okay, right. Boom. Okay, so let's get these answered. Okay. Right, so 68. So we've got a half. We've got 0.25. We have got 20%. We've got a quarter. We've got 0.4. We've got 75%. We've got 0.8. We have 1 over 8. We've got 50%. And we've got 0.1. Wonderful. Okay. Right, let's see these questions. They look quite long, so I'm nervous. Right. Okay, question 1. Sahar is taking a multiple choice test with 4 possible answers for each question. The probability that she answers a question correctly is 0.25. What is the probability she doesn't answer the question correctly? That is 0.75. John is playing a card game. Not a card game, I'm just adding in extra bits there. John is playing a game where he has a 60% chance of scoring a goal. What is the probability that he does not score a goal? So that's 40%. Okay. Question 3. Eva is attending a concert where there's a 90% chance of her favourite band performing. What is the probability that her favourite band does not perform? So that is going to be 10%. Question 4. Anand is flipping a fair coin. The probability that he flips heads is 0.4. What is the probability that he does not flip heads? Okay, so that's going to be 0.6. Lily is going on a vacation where there's 3/4 of a chance that it will be sunny during her trip. What is the probability that it will not be sunny? So that's 1 out of 4. Bob is ordering a pizza and there's a 4 out of 5 chance that it will have pepperoni as a topping. What is the probability that it will not have pepperoni? 1/5. Rizwan is buying a lottery ticket and there's a 20% chance that he will win a prize. What is the probability that he will not win a prize? Well, that is 80%. Question 8. Sonia is catching a train to work and there's a 95% chance that the train will be on time. What is the probability that the train will not be on time? So that's 5%. Question 9. Lucy is buying a lottery ticket and there's a 2% chance of winning the jackpot. That's a pretty good chance. What is the probability that she will not win the jackpot. That's 98%. Zella is attending a party where there is a 0.72 chance of there being live music. What is the probability that there will not be live music? That would be 0.28. Okay, right, let's get these marked. Right, here we go. Right, so we have got 0.75, 40%, 10%, 0.6, 0.6, 1 out of 4, 1/5, 80%, 5%, 98%, and 0.28. Yay! Topic 69. Right, here we go. Right, 1. Describe the correlation on the scatter graph using positive correlation, negative correlation, or no correlation. I would say positive. Oh, one sec. Fill in the blanks to describe the relationship in words. When the values on the y-axis increase, the values on the x-axis also increase. Okay. Question 3. Describe the correlation on the scatter graph using positive correlation, negative correlation, or no correlation. Okay, so this is negative. Fill in the blanks to describe the relationship in words. When the values on the y-axis decrease, I'm going to go for. It doesn't matter as long as these are opposite. The values on the x-axis increase. Okay. Describe the correlation. Right. Describe the correlation on the scatter graph using positive correlation, no correlation, and negative correlation. So this one here is no correlation. Which actually makes this last question nonsense, because it says fill in the blanks to describe the relationship in words. When the values on the x-axis, on the y-axis blank, the values on the x-axis blank. So I've put that there, and it's going to be in the mark scheme. That is a nonsense question. But that would be annoying if I was a student answering that, especially if I was working at it on home. Let me think. Maybe I could put something like maybe, if possible, fill in the blanks to describe the relationship in words. I think that's fine. If possible, fill in the blanks to describe the relationship in words. If possible, fill in the blanks to describe the relationship. Okay. Also, I think I can just arrange. Okay, that's nice. Okay, fine. Yeah. Okay. Yeah. NA. Right, let's mark that. Okay, so positive, increase, increase, negative correlation. That needs to be sorted out. Scenario questions. Let's go. 1. Describe the relationship between traffic collisions in terms of correlation. Okay. Describe the relationship between traffic collisions and temperature in words. When the temperature rises, collisions decrease. Okay. Describe the relationship between age and number of visits to the GP in terms of correlation. Describe the relationship between age and number of visits to the GP in words. Okay, the older you get, the more GP visits you have. Okay, question 5. Describe the relationship between daily hours of phone use and length of someone's daily commute in terms of correlation. No correlation. Describe the relationship between the daily hours of phone use and length of someone's daily commute in words. The length of your commute has no relationship with phone use. Okay, right, let's get these marked. Okay, here we go. Negative correlation, the warmer temperature, the less recorded traffic collisions. Yeah. Positive correlation, as age increases, so does the number of times someone has visited the GP. Yeah. No correlation. There is no connection between commute length and daily phone use. Excellent. Topic 70. Yay. Right. Okay. Here we go. One day there was 20 traffic collisions. Use the scatter graph to estimate the temperature in degrees Celsius. Okay, so 20 traffic collisions was here. If we read over to the graph, so this looks to me like it would be 21.5 degrees. Oh. I actually don't know if I like the wording for that one. Because one day makes it sound like that's one of these instances. So, yeah, I need to change that because that one day bit makes it sound like that's one of the pieces of data. So what I actually just want is use the line of best fit to estimate Use the line of best fit to predict what... Right, use the line of best fit to predict what the temperature... Use the line of best fit to predict the temperature on a day with 20... Use the line of best fit to predict the temperature on a day with 20 traffic collisions. What would be a reasonable number? Use the line of best fit to estimate how many more visits to the GP. Use the line of best fit to estimate how many more visits to the GP someone who is 20 would have had compared to someone yeah, that's fine. Yeah, that's fine as well. Use the line of best fit to estimate the temperature on a day. Using the line of best fit, what would be a reasonable number of traffic collisions to expect on a day where how many more Okay, right. They have all been changed. Okay, let's get back to the remarkable. Okay, here we go. So 21.5 degrees. Okay, that's been changed anyway. So 5 degrees. Oh, let's just check. I didn't edit that in a weird way. Right, fine. Right, let's get this marked. Yep. Yeah. Oh, no, this is very different. Oh, I went the wrong way. Yeah. Yeah. Excellent. And then let's get this last round done. Oh, okay. One day there was 440 traffic collisions. Use the scatter graph to estimate the temperature. 40. Oh, that's got the wrong graph. Use the line of best fit to estimate. Okay, right. Well, let's use this line of best fit here. Okay. Explain why it might not be appropriate to use the line of best fit to estimate the height of a 0-year-old outside of the data range. Okay, right, that might be it. Okay, so first things first, let's mark this and then we'll find out what's gone on with this graph here. And then we can fix that. And then that's the entire book reviewed. Oh, wonderful. Right. Yeah, so let's just get this one marked. Okay, here we go. Right, so here we go. 8, yeah. Approximately 22, yeah. 21 is approximately 22. Yeah, 8 visits. Yeah. Yeah, 1.6. Perfect. Oh no. What's going on here? That's question 4. Oh, that was 16. Approximately 18. Oh, now. Yeah, that is right. I don't know how I got 16 there. They visited for the... A patient just visited the GP for the 18th time. Yeah, I've drawn a line up at... I drew a line up at 17. 18's here. Yeah, that's about 18. Yeah, so the answer was right. Here we go, 1.6. Yeah, so we need to change that. And they're outside of data range. Perfect. So let's quickly change this graph. It worked. That graph worked. So that's good. So here we go. 1 second. Right, so that's... There we go. Right, done. So, I'm just going to take a bit of a break and then I'm going to read through all of those, and then later I can order my latest proof copy, and if that's all good, the book should be on sale by this time next week. So, brilliant. Thank you very much for everyone that's watched and joined me. I mean, if you're probably watching this in the future, you might even have the book and you're just kind of looking through this for answers. So, though I think you might not want to watch all of this because it's quite long. I will, when I get the time, edit down these answers into short videos that can be linked from the website. So that is something that will happen, but just when I have time. But perfect. Well, thank you very much. And yep, so long. All the best. Bye.